Okay, here we are. So, good afternoon to everybody again. Welcome in our summer camp. I'm Elisa Corro, the communication manager of the STRAND 4. Before to start the presentation, I would like to remember you that the lesson will be recorded and then uploaded in our YouTube channel. So we can start. And as a member of the VeDPH, I'm happy to give the welcome to Dominik Lukas from University of Chicago, our first external guest of the week. It is a pleasure for the entire team of the Venice Center for Digital and Public Humanities to have you here, Dominik, and thank you very much to accept also our invitation and to share with us your research work. Thank you very much. We are very curious about your topic and interested in these thematics regarding database and mining. So with you, I think that our worldwide virtual connection is now almost complete. So Dominik, welcome to the Archaeological Strand, and I give you the floor to Diego before to start. Diego, if you'd like to say something.
Yeah, absolutely. I would like to thank you, Dominik, for joining us. And I would like to say some word to introduce himself, to introduce him to the audience. I met Dominik a few years ago while I had the opportunity to work for some year in Stanford. And probably as many of you knows, the main archaeological project that Stanford University is running, thanks to the great role, not only for Stanford, but for the world of Young Order, is Çatalhöyük project. It's a massive archaeological project that every one of us knows about it. It is something that we studied in our textbook about archaeology. And behind this project, there is a rich and complex and ongoing system of database and data organization, and also this approach to data large was not only a thing that happened to the project, but was one of the objects of the project. So the project, since the beginning, reflected a lot about how to gather data, how to preserve them, how to use for internal research, and how to present to the public. The Çatalhöyük Lighting Archive, that is a complex set of databases, how many plural we have to add to that, has been ruled for long years by Dominik. And what I found very interesting in that is the theoretical approach. So not only the technical side of the question, making data working and being able to fish the data, but also asking themselves why we are archiving every type of data that we have, how, and what will be the final outcome of having them stored and managed. Dominik comes from Germany. He studied prehistoric archaeology at Leipzig, and then he moved to Berlin, working at the DAI, so the German Archaeological Institute, the very famous German institute, and then he moved to Stanford. Now he's working and studying in University of Chicago. So I leave the stage to Dominik, and thank you very much again for being here.
Thank you very much for having me. Thanks for the wonderful introduction. Feels good. Okay, so I will now. It's the first time for me to Google Meet, so I hope you can all see the screen now. You should be able to see the slideshow.
Yeah, I didn't mention that. Be free to interrupt ourselves if you don't have a connection, if you want to do question, and as usual.
Yes. So just maybe already at this point, I've now planned, so hopefully first off, I will be able to somehow tackle the questions and the interesting options that Diego gave me for this 1 hour talk. I'm absolutely sure that we will not be able to go too much into detail. I tried to figure out a way how to describe what database and mining under the title what we can do with that and what this means. But of course, there will be many open questions, and so maybe we can delve into that later on. I have separated the entire talk in two parts. So in the middle, I would suggest to have a little pause, and then we can maybe ask questions, discuss things that have occurred up to then. If that is not necessary, I can also go on. So let's just see how it works. The structure of the session is the following. We will first talk about some theory concerning the rawness of archaeological data. So what does it mean to talk about data? What is raw data in archaeology, and how raw is that raw data? Then second part is the data modeling aspect. So primarily a very short introduction, of course, to the relational data model, which is still, although there are many other data models out there, the main structure in how we, in archaeology at least, store our data and then of course try to retrieve the data again. This is the first part. Second part will be about ontologies. Most people will have heard of that. I will give an introduction to what that means and what that actually does for us when we have data and we want to make more of it. And I will end up with some real-world examples. I will then also talk about the project that Diego already mentioned, that has been developed with Stanford University and the Getty Foundation, and the Living Archive of Chattanooga.
Okay, you are going. Okay.
We're here? Okay.
Second.
Sorry for that.
We are. Absolutely.
Okay.
We have the punk word.
Okay, so let's I will just show those results again. So there's the clash that I said and I talked about. Then clock TVA. I'm not sure how many people know that. It's the same era. It's quite experimental, but most people would maybe call it industrial and new wave, but still we're there. Then again, the offspring is more something for people of the 90s, and most people of the 80s, of course, would say, no, offspring is no punk. But then we have something like this. And now I'm not sure how many people know Bryan Adams, but most people that know him would not call him punk. Yet, in the Spotify dataset, in the raw data of Spotify, that was part of what people understood to be punk. So some people might maybe say, okay, Spotify is maybe not the right source, so maybe one should ask some experts and have them decide, right? We make an expert system on that and have them decide what is punk. But I guess actually that would end up in much more controversy, because as yesterday I made this presentation, my wife looked over my shoulder and told me, what, the Clash punk? No. So here we are. What do we learn from that? That is that. What has this to do with archaeology? So we have here an example, an illustration by McVicar from 1985, where he discussed already the question of what of the computer will be or could be in archaeology. So we have on the first, on the left-hand side, the pre-modern data heap that is actually the excavated data, right? And then this happened to become, with more professional excavations and so on, the data heap got always bigger and bigger. The hope then was that after the micro, so when with the advent of computer technology, we have two different views. The optimist view that would have said, okay, yeah, of course, the computer, you see him with the corona of holiness on top. In the optimist view, would be able to sieve through the data and, of course, separate it out. And the happy archaeologist in the ditch is actually, yeah, he learns. But then we have also the realist view, and that is shows a devilish computer that actually does nothing else than just put the data back on the archaeologist, and he's just overwhelmed and will die from it, I guess. The optimist and the realist. I have a little quotation here from Harris from 1975 that I would say is more the realist, or actually the pessimist view. The introduction of a sophisticated sorting device into this essentially human occupation would be anathema, for the quality of such reporting depends on a person's intuition and undivided attention to his stratigraphic problems. An excavation and its comprehension is subject to constant change. the excavator should not be bound by a preconceived program or the necessity to allocate time for consultation with a computer. Interestingly, many points I think in this quotation. The first one, of course, is, and I think that is actually up to now a very recurrent position, that the main question of the data is, of course, not the data itself, but the interpretation that we make of it. And there, so this is the statement, the archaeologist as a person and not the computer is the central actor. And the second part is, and this is of course shows us Harris in 1975, that he is not very happy about the idea that the actor should actually have the necessity to allocate time for consultation with a computer, while we see nowadays that, I mean, there's nothing else that we do, right? This actually also the pessimist or the realist view actually has developed over the years, and now we're talking about something like the mid-2000s and maybe even still up to date. A situation where with the data deluge, how it is called, or the advance of big data, has furthered an idea that is unfortunately not too uncommon, that we can talk about something like the fourth paradigm. That means paradigms, of course, understood in the sense of Kuhn, so the scientific revolutions, right? We have paradigm shifts that change what science is up to do, what scientific understanding is in itself in different disciplines. And those shifts are understood as paradigm shifts, so everything changes from one shift to the other. That is maybe not more important than that to say now. What the idea was, and this is Hay, Translate, and Tolle, in a book that actually has been published by Microsoft, I think, is the fourth paradigm. And that means that the idea is we do not actually need to go back to the real data, so the place where the data comes from, so the actual physical confrontation with what is out there, but data itself can be the goal, can be the scope of that new empiricism. So data in itself is then understood, of course, as something that is raw, that substitutes the actual interaction with the world. And I'm not sure if this, at least in an archaeological perspective, can make too much sense. Another aspect of that is a paper that has made big waves in the 2008 and further on, of course, was a paper published in Wired. Most people will know that magazine that is, of course, very important for the IT world and actually the IT culture. That was the end of theory. The data deluge makes the scientific method obsolete. And that hints and goes actually into the same direction to say, we do not really need to talk about the theoretical implications or the interpretations of what we make of the data, because the data itself is already in itself what needs to be examined. What does this do to us? So what in a situation like this, what is knowledge about? Is it necessary that we will end up in some kind of an epistemological relativism that actually points to that? I would like to start there with a very short introduction to what is the theoretical, archaeological theoretical environment when the first field recording systems were developed and when the computer held his first audiences in the archaeological world. The entire idea stems or comes into being in a situation where archaeology was thought to be scientific. So we have here, of course, the most important proponent, Binford, and his processualists that were deeply inspired by the philosophy of science. Philosophy of science in that sense has to be understood not as philosophy in general, but a very, very specific approach to make philosophy a discipline that analyzes what we are saying when we talk about the world. So to try to create some kind of a unifying of a singular language that allows us to talk about everything. That, of course, is based in the logical positivists. And here I have a little quotation from Joseph Weizenbaum, who himself was IT expert, who said some years ago, a group of Viennese logical positivists, we talk about the 1920s, 30s, 40s, started a movement devoted to achieving the unity of science. They failed. In any case, and this is also something that in philosophy of science has actually been recognized, that there is no way of unifying science. On the other hand, in archaeology, this approach has in fact had a strong impact. And in fact, if we talk about the rawness of data and in how far those field recording systems are actually still conceived, we have to say that this impact is still lingering. And although we have then advancements, especially when we talk about, and here I want to refer to what Diego talked about with the impact of Ian Hodder, of course, and the post-processualists in the 80s, the recognition that knowledge is actually always socially constructed. So this derives from, this is an aftermath, of course, of the work of Latour and Woolgar, laboratory life, and Ian Hacking, for example. So people that are more interested into this question, I strongly advise you to look especially into Hacking, who is a very critical, self-critical person and very nicely to read. So the problem then is, of course, if archaeology as a discipline creates data that in fact is not unifiable, cannot have the fallback solution of having a overall philosophy of science structure into which we embed our data, what do we do then? And in fact, if we look at the subsequent years after the 80s and the archaeological theoretical discussion there, we see a lot of diverse approaches that have nothing to do anymore with the idea of unifying theory, but actually of diversifying theory. So we talk about the material turn, we talk about the ontological turn, where each cultural set is attributed with its own ontological scheme, and no culture could be understandable from the outside, but only from understanding the inside. I will not go too much into that. Interestingly, and I want just to highlight here the term ontology, because we'll get back to that. But what I want to keep you in mind, want you to keep in mind, is that ontology is not the same in philosophy or information technology and so on. So the question now is, and from the epistemological relativism, we come to the basic question: how raw is now raw data? What is raw data actually? And if we look at this little schema, it's just trying to show you the ambiguities here. So we have in the center a triangle of knowledge, data, and information. What is the core of the scientific or any research discipline? And now then we have the problem that the interdisciplinary linkages in between archaeology, information technology, and epistemology actually do not fall into each other in this triangle, but every of them has their own approach to this triangle. So we have information technology that actually asserts, or necessarily asserts, that anything that is stored in a research database has to be understood as being a true fact. If you do not do this, you actually have a problem because you cannot analyze your data anymore. So there is already something that says we do not need to talk about the epistemology of things. Things that are already stored are already true. And then, of course, we understand better how people from publishing at Microsoft publications can say something about a fourth paradigm or the new empiricism. Then we have a second part that is the epistemological aspect, of course, that then, in fact, deals with all the rest. So everything that says, how is our knowledge structured? How are human beings dealing with whatever they learn, whatever they research, and how do they come to terms and create knowledge by that? Of course, there's the social aspect then inside there. And then we have all the archaeological residuals, so everything that then is archaeological theory on top of that. So we understand already here that while we talk about a core idea of data and knowledge and information, it actually depends very much on the point of view that you bring with yourself onto the data to make sense of them. Let me just step back 1 second now. So what I did up to now was trying to sum up in very broad terms what is the theoretical underlying idea of talking about data in research in general, but in archaeology in specificity. What I want to do now is go a little bit more into the detail of how data is constructed. So that is a rather dry topic, and I will try to sum it up in short terms, but I think it's necessary to go there to then be able to better understand also what ontologies do, but also why it is important to think about when we have a research project, how do we actually put this into a data structure, and what does this actually give us as an aid, but also constrains us to certain aspects. The basic idea then here, and I will talk mostly about field recording systems, most importantly because it's the biggest aspect in archaeological data storage, I think, and secondarily because I want to show you a little bit about Çatalhöyük, and in fact what Diego already mentioned is that Çatalhöyük has been known famously or infamously for its database. So we have here a list of what are the requirements for field recording system, again from the 70s, but more or less it's still relevant. So first is the independence of period or region to all remains of the past. The idea then that remains of the past have a certain requirement for how they have to be stored independently of what period or region we're actually talking about. Interesting. Second, the reliability in data storage and retrieval. I think that is self-explanatory. Possibility for modification and extension of content. That is actually an interesting aspect, because if we think about a field recording system that fulfills our needs at a certain point in time, and then, as everybody knows, a research project develops itself further on over the years, like in Çatalhöyük in 25 years, we will see that the modifications actually delve very deep into the data structure. So what do we do when a data structure changes, while we always try to have the data structure as that one big framework into which everything should fall in place? So we already have a discrepancy, actually a contradiction in itself here. We have a maintainability and usability with minimum effort and training, okay? And yeah, you need a database developer for that. And then the accessibility and ease of use, and that's an interesting point to say that we have different stakeholders that all should have the ability to actually use the same type of data. We know, of course, that different levels of expertise allow for different ways of dealing with data. And so having different stakeholders do the same things with the same data is a very, very big concern. But of course, it's a requirement. Let's start in the base. I actually have no watch. What time is it? Okay, I'm good in time. No, we can also, anybody has any questions up to now? Are you still there?
We are, huh?
Yes.
Crazy with his silence.
Okay, I will just go on, then we can discuss in the meantime. Okay. So let's look.
People say that is clear, huh? In the chat. So go on.
Okay.
Yeah. Everyone is saying that all is clear.
Thumbs up. Very good. Thank you very much. So let's look at the data. I think most of archaeological projects start at least here, or remain also here. But even in a project like Çatalhöyük, and I have a little chart afterwards that will show that where you actually have the need and the centrally, also administratively enforced a requirement everybody use the database, is that everybody works in their own Excel sheets, of course. So we have here one example of a project in northern Italy about funerary practices. And we know, of course, in archaeology, that those really big Excel sheets with, 50 columns and 10,000 rows that are interesting in itself, but that, of course, have put problems into retrievability of data, the standardization of data inside, and so on and so on. And actually, what we have here is something that one can call a one-to-one database. I will talk about this in an instant. But of course, this is the basic principle of most beginnings in archaeological research. Another example, and in fact here we actually most of the time, not only at the start but already at the end of the complexity of data, if we talk about GIS, most of the time we talk about data that is contained in attribute tables, and those attribute tables are again like Excel sheets, one-to-one relation databases that do not allow for a big complexity. Of course, we have different layers, and we have different layers here, like the landmarks. Then we have the National Register of Historic Places, school grounds, and building footprints of the area here. And each layer, of course, has its own attribute table. The problem is that all those data sets are not interrelated with each other, but they are laying, of course, above each other. So the only way of querying them together is doing that by geospatial querying. But the data itself, so the textual core of the information, cannot necessarily be queried aside of that. So the requirement here is, and some of the GI systems, so the GIS, have tackled that question, especially QGIS, I think, has now a plugin developed in Switzerland, I think, that allows for the implementation of a relational database inside QGIS. And that is where I want to go now. That will be a short introduction of what relational database management systems are about, how these are constructed, and what is actually behind that. So the idea is that when we conceptualize a data storage, a database system, like most commonly a relational one, what does this do with our data? So how do we get our data in a senseful way into that? An example here would be a system that is, of course, an ideal system. So there is no, that's not a really a system that is in use. We have different tables. So the blue boxes, right? The entire thing is called an entity relationship diagram. We can forget this immediately. And the idea is that we have different tables. So think about it like in Excel sheets. And then we have different columns, and those are called localization ID, for example, geography ID, sources ID. And those make tables interrelate by having the same ID here, localization ID in the same table, in different tables, and this interrelates them. So let's say in an example, no, I will give an example right now. So we talk about maybe something archaeological. We talk about a sherd of a ceramic vessel, which is, of course, a data that is inside an object table. And this has been identified within its context. What does this mean? So we connect the information that there's a sherd of a ceramic vessel in an object table, and via an identifier that is the localization ID, we allow the linkage to a localization table that then allows further to be linked to a source table that says, and based on map, it has been geographically referenced. What this means is nothing else than we have an object that has a geographical localization, and that localization is referred to something that has been published previously. So let's say, I think it's actually it's an amphora, I don't remember, that has been published. Someone has published something about those types of amphora, and we want to interrelate all this together. Then again, the object has been dated. So we again, by the object, we go into dating. So we connect to the dating table, and based on a typology, and we are here with Michel P. So yes, we talk about Mediterranean France, and therefore has its origin at around 625 to 525 C before Christ. Sorry for the German abbreviation there. So what happened? We have a set of tables that are very technologically interrelated. So the localization identifiers actually are nothing else than some numbers or alphanumeric codes. And the actual information is then stored in secondary columns where the actual information resides. Interesting is that the structure here allows us for saying something that is rather basic. Yes, it is rather complex information from an information technology point of view. But what this does is that we do not run into problems like in a big table, having everything into one column, to interrelate also maybe a localization like the place where the ceramic vessel has been found with other objects that also have been found. And why is that? We see this here with the things that are here in brackets below, n to 1, which means that we have n objects, so more than one object in the object table that relates to one localization. This means an object can only have been found in one place. I think that is trivial, but of course in the same place we can have many objects. So we have some kind of a relationality, cardinality, that allows us to structure our information and to not set up the same information for the localization all over again. For example, in an Excel sheet, if you want to talk about an object that has been found, we talk about again back Chicago, in a certain building in the south side of Chicago, we do not have to repeat, we do not have to create redundant data by adding that into each new line, in each new row where something comes from that place. And that's just one aspect of it, but I do not want to go into that further because I will run out of time, I fear. Just to sum up a little bit, that's of course a very short introduction, and it would require a certain amount of time to really discuss these issues, the tricky parts. So the things that I want you to keep in mind is relational data models are represented by entity relationship diagrams, that is that. Tables are related by key relations, so those are the identifiers, the IDs, right? We have primary ones that are the ones that organize the table itself. And then we have secondary ones that relate to other tables. So the secondary, the foreign key in one table is another table's primary key. Actual data is organized in columns, in attributes, and rows. So that is something that we have in Excel too. Then we have the cardinality questions, or the relationality of tables with each other. And then there's something that I have not talked about, that is normalization, that maybe in this, now at this point, I just need to say it's the attempt to atomize data as much as possible in order to ease algorithmic processing, so to make it easier for the computer to understand it. The problem is the more you normalize, the more tables you create for very, very atomic data, the less understandable it will become for the human. So there's actually a social problem here, because when we think about not only someone has a research project and wants someone else to build it, and then he wants to use this system from here to eternity, then of course he doesn't need to really know about the interior structure, right? But as we all, I guess, thinking about the relativity of interpretation, the relativity of data itself, the social constructedness of data itself, so we need to know what the database is actually about, then of course we cannot atomize too far. That's only what I want to say here. Yes, okay, those are the identifiers. Okay, as an example, we are at Çatalhöyük, of course, so we see here in the little picture the north shelter, which is quite awful to dig in. You get 50 degrees down there, so it's an interesting example for beautiful architecture that has functional deficiencies. And the situation here is that we have, of course, an on-site Wi-Fi and all these. We do not need to talk about this. The important aspect is that we have database tables, database parts, sets of tables that talk about the excavation, that talk about the diary, so the experience of the excavator while digging. And then we have also all the other systems like groundstone, laboratory, whatever, human remains, faunal remains, heavy residue, and so on, that all deal with aspects of the same data. So everything that has been retrieved on site is brought to the dig house and then examined. And I think this is a situation that we find in many other places, in at least bigger research projects. And all in the background of all that, we have one big relational database. How does this work? We have, of course, the standard procedures. Now with digital archaeology, of course, we have tablets on site. I have to say that the Ian Hodder part of the project has been ended in 1997. So, but the people that have taken over, it's a Turkish project now, are using the same tool. So that is valid also there. So we have different types of recording. We have also people like in the lower left side that still prefer to do their recording on paper. But whatever happens, if you do it on site or you do it in the evening, data goes into the tables. And they do this by using a little MS Access front end. We don't need to talk about this. But again, what we see here is that all these tables are again of the same basic structure. We have the diary tables on the upper half, and we have the excavation tables on the lower half, and everything is related by that one unit ID. So the unit ID is, of course, the archaeological context, which is the main core entity. And then, of course, again, and I want to just say this now, and afterwards we can talk about this in detail. Although we use single context archaeology, so the unit is the core and is the main organizing principle in the database. And other databases, of course, do the same thing, because field recording archaeology is mostly about we have a single context, or we have one context that is the core, yet every project in detail deals with that and with the context of those units in a different way, and that actually makes the discrepancies and divergences of these systems. An example here how this works in reality is here. So we have again tables and links, right? So this is the unit table. Those are the single contexts. We have here 1030 from 1995, so very early excavation. We have then a table that is called a cross table that actually does nothing else. So this is a very atomic, a very normalized table that does nothing else than saying, okay, we have a unit 1030 and we have a feature 12, and those are somehow related. It doesn't say anything about how they are related. They only say the unit is in association with that feature. And then we have the feature table that then tells us something about feature 12. That's it. So that is the functioning of that. That is quite simple. Bear in mind that the system at Çatalhöyük has 1,000 of tables like this. So, but in principle, it's that simple. We get, before I want to have a little pause and maybe discuss what we have talked about up to now, just show you as an indicator that even a simple situation, okay, we have a unit, and the unit is the core principle, and the unit relates then to all the other information, is different already here with other systems. So for example, there has been in 95 someone trying to build an ideal schema, and that is something that is recurring. People that think, okay, we can actually do the one all-encompassing system that covers everything and everyone, and they try to analyze how things in archaeology really are. And so we see here excavation unit is connected to an internal stratum, and that internal stratum lies within a square, for example, okay? What we do not find already here is something that would be called a feature. So what we have in Çatalhöyük, feature in that case would be something architectural, an architectural, more complex thing that is built up of different atomic units, okay? Something like this we do not have in the system. And for example, we also have another problem that the internal stratum lies within a square. So of course, what we understand here is that that system was built for people that dig in the in the classic checkerboard tradition, something that in Çatalhöyük has never happened, because a layer is followed up to the place where it goes. Okay, let me stop here for a second. Do we have questions?
Yeah, Lucia, thank you. Turn on your mic.
Yes.
Very welcome.
Hello, thank you for this brief but very intense presentation so far. I wanted to ask you about the when we are applying the relational database management system, and you said that the Unity ID is the core info, and if I've well understood, the Unity ID is well, the stratigraphical unit. So you're not okay. So what happens when you're, because of the you're doing your matrix and you happen to it happened to you to understand that two stratigraphical units that you would have distinguished before are actually the same. What does it change in your or just another table to be used, another?
So that's a very interesting question. It's at the core, and it's yeah, I mean it starts here, right? So it depends very much on what system you use. It's a stupid response. I'm sorry. I will try to explain. Let's compare, for example, a system that I think in Italy is still or has been in use very long. That is the Unità Stratigraphica, which would mean the idea is that if I find inside a house a certain layer, I expect that layer to go very far. So it does actually, in theory, extend over the trench where we are in. We open another trench, maybe a little bit distant from that. We go down, we see a similar stratigraphy. We find the same yellow, whatever layer that had a certain number in one trench. We give it the same number, right? And then the question is, what do we do if that is actually not true? Because there's a wall in between and we haven't seen that. The idea would then be use another system that, for example, the Chattanooga system would say the unit has only once a number that is in that trench. It cannot be the same already in the recording system from the beginning, because this is an assumption you have no basis for. Of course, you have the idea and you have the expertise of the archaeologist, and oftentimes it's true, but you should not assume too much when you're talking about the raw data, about the data that you fill in. So actually the idea would be you do something like Unità di Scavo, Unité de Fouille in France, or in fact in Chattanooga it's that. So you have the number for the one trench, you have a different number for the other trench, and then you can create maybe another unit that says this encompasses the two. And then when you want to talk, when you realize, okay, it was really the same, because you dig also the in-between section, then you can say, okay, so we have then three units that are the same. And if you want to talk about the sameness of these three, you use the number that is the 3, okay? That's an idea. It's really, that's actually not a question so much of the data theory, but of the excavation method and what system you apply. But as you see, and that is an important question here, that all inflicts on what the data is there. And for example, and I want to say this now, and we will come back to that. Let's just assume, and it's really a good example, someone has dug in the Unità Stratigraphica system, and then he puts this up online, right? So there is a table with all the units, and someone from Great Britain maybe looks at the same table and says, oh, it's units, so it's single context, right? They have a different concept there. If they want just to retrieve that, and what happens nowadays very often, they mine the data from that system, from that archive, and they just use it in their own conception. They will mix up the data. There will be really big errors there that cannot be resolved, because there is no real theoretical and information technological knowledge or transparency on those different types of systems. And that's something that I want to hint at. Thank you very much.
Yeah, may I have myself a question that is quite related to Lucia one. Sometimes my student that we are using in Venice a similar system, not so advanced like Chatal one. But sometimes students ask me the first time that they have to feel using the tablet or the tablet on site. They are asking similar question, that one, what happened if, what happened, and what I say them is follow the flow given by numbering the strata, entering the data, and so on. And then it will end to have exactly what you said. So if you have a second US stratigraphic unit that maybe is equal or not, it doesn't matter. You have to give a new number, and the equality will be assessed in second time. But my question is, do you think that working digitally in the excavation, I'm referring to your picture also that you had before, with the archaeologist, with the bucket of dirt and the tablet in the other hand, is changing a little bit the process of excavation. So he's introducing a thinking time in the meanwhile the excavation that the paper sheet is not, or is absolutely equal to the paper.
So did you please explain?
Entering the data digitally from the very beginning. So you don't have a raw material or paper material, or you could have, but ideally you don't. So the data is digitally born. When you have things like that, it is affecting the way that archaeologists excavated or not, in your opinion?
It depends again. Sorry, I'm really sorry about saying these things, but it depends very much again on the system that you use. So there are, of course, examples where, and Chattanooga is actually a very good example for that, where the digital method replicates nearly one-to-one what had been on the paper before. And actually, people still use the paper up to 3 years ago. So interestingly, although Chattanooga has been one of the first ones that had a big database, the fact to have that system in place since the beginning actually made it very, very difficult for people to change that system later on. So that's another aspect, but we do not have to talk about it. But actually there, you would need to think about that very strongly, that the simple replication of the data record type into a digital type does not work. The digital means of doing things, the digital atmosphere, impacts very much of how a system has to be conceived. Actually, we have to free ourselves from the paper records, because we still deal with the digital data as if they had been on paper. And in fact, in many parts it is like this. The interesting thing would be, but I mean that's the next step. We need to create systems that are conceived digitally first, and then we can also tackle things like we can actually make sense of the positive aspects of digitality that are not constrained by paper and so on. So as an example, how things could go the other direction was that when we started with the digital, so the tablet on site, and we had the same excavation front ends that were very much similar to the paper, people realized that when you had a folder with you, a physical folder with the units, what you would do is you have your folder with you on site, and while you're digging, you're also checking the units that are next to it, right? And you're always with your hands in the folder and trying to figure out. And that is something that in the digital model, in the digital program, didn't work. So we had to reconceive something that would show all the units that are in the same area, in the same space and so on, so that you could tab through and use that in that way. So really like a folder. So it's really interesting how things like that change the way we do things. But I think it's really necessary to step back a little and think about digitality first, in order to be able to not just create a bulk of more data. So think about the picture I showed you in the beginning with the poor guy that had a devilish computer and is swamped by the data. Yeah. That is what actually happened. And we are now doing a lot of data creation. We really create big data with 3D models that are I mean, how many pictures do you use for your 3D model and so on for photoscan models, right? All that data has to be processed, has to be analyzed, and we lose more and more time. So the idea, computers and digital technology should aid us in maybe having more time for really thinking about the context and so on, has most of the time gone away. And that's an important question, I think.
That is a very important thing that we should go back on that. Thank you very much.
Okay, so I see I have 9 minutes.
You can, we have a half an hour of space time.
We have a cushion. Okay.
Yeah. We have a cushion because so maybe not all the
yes. Don't give me too much time. I will try.
It will be a pleasure.
I will try. Okay, let's go back to that. Here we are. So hoping that this works. I will just go back to actually threw a firmware update on me now. Okay, here we go. Ontologies. So I will try to make it short now, but I think it's possible because the things that we discussed just before with the questions that you had points very much into the direction I want to go at this immediately. So the question of what do we do with different types of approach to the data? Can we actually make them work together? Because we learned just going into an archive, pulling all the unit data, doesn't make sure that we actually have the same unit as we maybe have in another project. An interesting quote here from 79. I seem to have most of the stuff from the 70s which feeds back good to the punk question, of course. Do computers have an archaeological soul? Computers have been very widely used in archaeology as a serviceable tool to speed up data analysis or the sheer handling of data reduction, etc. We have seen that. They have not been used so much as fully interactive participants in field operations. They have become instrumental in detecting patterns of relationship in various sorts of data, but this function is again superimposed on the data, not effective when the data are generated. So what does he point at? He actually says that the computer is a tool that is secondary, that is adjunct, but has nothing to do with the actual workings of archaeology. And this points into a direction that we had the Harris quote before. The actual archaeology is done by the humans, right? What Federle is actually pointing at is something that has been developed in the 70s, 80s that were called expert systems. That is to be seen in context of the first strand of artificial intelligence. So making the system replicate cognition and understanding and ways of understanding how the human being is thought to do it. And that was the idea. Another quote, intelligent knowledge-based systems, IKBS, or expert systems, and that is actually the name that most commonly was used, for short, are considered to be the in thing at present. So in the 80s, everybody was talking about expert systems. That stopped at a certain point of time, but not really, because 80s, 90s, we saw the increase of work in ontologies. And maybe people have heard of the SciDoc CRM. I will go discuss this in an instant, is the question of ontologies. And we have here the definition by Thomas Gruber, Stanford University, 93. Ontology is a formal specification of a shared conceptualization. That sounds simple, but actually says everything that needs to be said there. So a formal specification, of course, the replication in formal ways of what people deal with when they deal with the world. And that is, up to this point, we are still in the question also that we have with the relational database systems. We conceptualize our data storage based on how we could perceive the reality of the archaeological context. What comes into place here on top of that is the shared conceptualization. So the idea is that we have many different systems. We try to trace what aspects in these systems deal with, and then we try to map. That's the term that most commonly is used. We map those different aspects onto each other. So we have two different units that are discussed in different systems. Still, there is something that is about these units that is similar. So the fact that it's an excavated post hole, for example, is the same in both. They are just some additional attributes or some different embedding into the entire data storage is different. And that needs to be made transparent in order to make them work together. So this is exactly where we want to go to. The example SciDoc CRM here is an example, and this is it at first looks very, abstract. But actually, when we think about the details of it, it becomes clear. We have actors, events, time spans, places, and physical things in this system. The central part is the event, in the sense of, if we think about a post hole, there has to be understood to be an event that made the post hole. So there's the first event that made the original post hole. Someone was digging it in order to put a post. And there's also other events that dealt with the same unit, latest being the one excavating the same hole, and this would be the excavation event, right? So what this does is it attributes general assumptions on the coming to being of the archaeological record, and by understanding that in a transparent way, by theorizing it via a central ontology, we can recreate the linkages of those, because either the one in Italy, the Unità Stratigraphica, has been excavated at least by the excavator, right? And came into being in a certain way of the dealings of the past. And also the one in Great Britain did the same thing. Although they have different archaeological conceptualizations, in the end they do fall into each other, right? So that is that. what we just might hint there is that also this ontology now, although it is thought to be a generalized model, also shares the same problem as everything that we conceive of in the humanities, in human research. Event-based modeling, as this one, is actually something that derives from the studies of phenomenology. So we talk about Husserl and we talk about Heidegger and all these guys. The idea of an event, or actually later on, and this is the basis for the CDOC-CRM, theoretically is Davidson and Quine, that everything is best understood as an event, or in its movement through time, instead of seeing it as an entity that is somewhere out there. I will leave it there. So what does the CDOC-CRM do? It does the modeling of a domain knowledge. The domain in that case is the archaeology or the cultural heritage aspect. We have the event-based modeling. It's extensible in the sense of there's a core CDOC-CRM, and then there are some extensions depending on what you want to do with it. So for example, there's CRM dig, which is, I think it's the archaeology part, but I'm not sure. And then there's CRM geo, which does this geospatial referencing and so on. Okay, and it's used, what is it used for? To standardize and to interoperabilize. So to make it interoperable, to make databases that are distinct at a certain point of time by means of the ontology become interoperable. That's an ideal assertion, of course, but there are things that work. Çatalhöyük is doing something similar, and in fact, we're also inspired by CDOC-CRM in the way that we have different classes. This is what those bubbles are called, and their relation towards each other. It is similar to some extent with the CDOC-CRM, but yet it is distinct. And the approach that we chose in Çatalhöyük is because we are aware that there is a theoretical implication in the data structure itself. We need to first model an ontology based on the data structure in order to cover all those specificities. And then we can, in a second step, see whether there are classes that we have in our ontology that map to the CDOC-CRM and further on to other systems that use the same ontology. Yes. An example, and now I think for the rest of the talk I will just have some images to show what this can help us to do in a real practical way. What we have here is an example of an image that shows a skeleton of a certain unit that is 21,732 and it's individual 1, and the bones that were still recovered in the dig. So we have the black ones, the gray ones are the ones that are fully preserved, and I think the gray ones are partially preserved. What in the background of that image is actually nothing else than a table, set of tables that have 3 numbers, 0, 1, and 2, where that refer to the preservation aspect. So 0, I think, is the non-preservation, I guess, and 1 was full and 2 was partial. In order to visualize that data, we created an SVG mapping. SVGs are vector graphics that are used on the World Wide Web mostly, that are actually XML files. XML files are files that are human readable. XML is actually on the basis of HTML, so the web language, and many others. So it's a structured database. Actually, each XML file is a database in its own right. And what we do is we map parts of the object, so the bones, to nodes in the XML file, like here the radius B, humerus A. So humerus, I think, is the upper arm, and radius the lower part, so one of the lower arm bones, and they are highlighted by its existence in the archaeological record. That sounds like it's programming, but yes, it is. But yes, again, it's also already something that we can understood as a mapping of ontologies, the ontology of the SVG file onto the data that we have in the archaeological record. Another example would be a DAE mapping of architectural entities to a database. DAE is again an XML file, is used in SketchUp, for example. It's the successor of Collada, I think, of the Vermal and so on. So yeah, virtual reality markup language. I think there are people that have worked with 3D reconstructions that will know what I'm talking about. And those, again, can, so each column in a certain reconstruction, right, has a certain node in that XML file. And in the database, we have at least the background, the post hole, or the preparation of the floor on which the column will stand, that is preserved in a record. And these two can be linked. So for example, we have here a domus in on Montbévray in Bibract in Central East France, Burgundy. And we did a reconstruction of that here in 3D and so on. And we have all the features that we have here, of course, are based on whether a wall is preserved or not and so on. And we can, of course, then highlight which parts are based on the real archaeological record and which is only interpretation. And then we can create, of course, reconstruction and so on. And the fun thing is here, we actually had the possibility to inverse the digital tendency going back into the physical. So they use the model to print, no, to actually excavate the model from a big block of granite of marble. So that was nice. Another example, and that is just the same question. We have here a record that is again an excavation in Bibract in Montbévray. And here we see the red parts of the model are the ones that are based, so directly based on the archaeological record. And then we have the brown things that are more an interpretation. And of course, it's the upper parts on the wall, so the beams in the house, the horizontal beams and so on, of course, have not been preserved. And then we can actually reconstruct the same thing. And then we can also show what parts are based on the reality and what is then interpretation. So what we do is actually parameterized interpretation. And in that way, we do not only have the record and then the resulting, what is most often the case, the resulting reconstruction, but we can also retrace the steps, the interpretative steps of the archaeologist, of the architect that did the reconstruction. And we can compare different approaches. So here, left and right in the lower part would be different ways of perceiving the same record. Then we have here another example, and that is just interesting if you want to look at it. It's one of the most detailed things. It does. It is a database, the Whiskey platform, which is a very well-known system that is developed in Nuremberg, Erlangen. That is a platform for exposing data via OWL, via ontologies. Let's not go into that. And they did use that system for the integrating of 3D models of different aspects of a Prussian palace. So here we have, for example, a fireplace that has been scanned 3D. Then we have here the point cloud, and that is all linked together with the entire data set behind. So we have the 3D aspect that is totally immersed into the textual information. Last thing, and then I will just have 1 second talk about the living archive, maybe 2 minutes. It's good that I cannot hear you. I can just go on. The interoperability aspect, and I just want to show you here a system that is called Open Context, which has been developed in San Francisco, Berkeley. It's a system that actually ingests different data sets. So it's an archive for archaeological data storage. Other things like that you will know from one of the precursors, the early ons, is the ADS, so the Archaeology Data Service in York, in Great Britain. They were the first ones, Julian Richards and so on, and his colleagues did that. And then there is TDAR, which does the same thing, and they sit in Arizona, so they cover the United States. But there are other systems, I think in Germany, they built something like this. I'm sure in Italy there's something like this too, but it slipped my mind, sorry. So Open Context actually contains already Çatalhöyük archaeological data, and they expose that again via ontology. So what we can do then with, and that is what I show you now, with the Living Archive, connect all these data sets, because that is another aspect, because Çatalhöyük has been always an international project with universities participating from all over the world. We need also to link those data that are already out there and are already present again, to make them understandable. And that is very easy, or let's say it helps a lot if they're also already exposed via ontologies. So the Living Archive now, what I want to show you here is only what I have been talking about under the surface all the time, is those differentiations in between the unit and the unit conceptualizations in different databases. And what we have here is actually a comparison of 3 ontologies. This is the English Heritage ontology, which was an early ontology based on the early versions of the CDOC CRM to understand the excavations in Great Britain with single context archaeology. Çatalhöyük is actually similar to that because they collaborated with MOLAS, so Museum of London Archaeology Service. So a lot of this background work has actually been embedded also in Çatalhöyük. And then we have a third thing, that is the CDOC CRM with its extension. So this is the latest one. And what I want to show you here is that don't want to go into detail here, is the difference of those two, and then the similarities that have actually reached a level where we are nearly able to completely map whatever we have onto this ontology here. So the question of the unit with its stratigraphic relations and the different types of units, cut, layers, clusters, fills, and then the conceptualization in the CDOC CRM that we have a stratigraphic unit, a stratigraphic volume unit, and a stratigraphic interface that somehow, I'm not saying it's 100%, but we get close to what the cut is. The cut is actually something that is the stratigraphic interface, yet only if we talk about post holes. Then we have the volume units that are all those units that actually can contain finds, right? Because there's earth, so which would be layers, layers and fills. And we have the unit that encompasses all these different types. And here we again then also, and this is something that I have hinted at, we have the problem with the features that have not been part of many other systems, yet we find something here in a last extension from 2016, I think, that actually does use CDOC CRM for architectural features. And we can actually map something that is the feature with stratigraphic building units and morphological building sections. So we're getting there. What I want to have you keep in mind is that with ontologies, we actually can trace different systems and map them onto each other, but there's always a little detail there that will not work. But then it's also a question of a pragmatic approach to it's better to map things together instead of just having pools of data that do not talk to each other. I do not want to talk about this, but this is just an example that is using natural language processing on computer code to analyze the modifications and the development of a system. This is the excavation database part of the Çatalhöyük database. So in which year, what parts of the system have been modified? So what we see here is, of course, if it's already that difficult to create an ontology that covers a system at a certain point of time, then of course, what do we do with that same system that actually has a development over 25 years, or here covered a little bit more than 10 years, and its modifications? So we have to keep that in mind and somehow make that transparent. Something that I had hinted to before was that, of course, we talk Çatalhöyük, we talk centralized database and so on, but of course, what we have here is all the file types, or let's say the standardized view of the file types that we have in the file storage of Çatalhöyük. And we see we have a lot of text files, PDF files, of course, XML files, GIS shape files, so GIS files, right? Other GIS files, database files, and all those are not linked up into that big central database. And all these data sets, of course, are again even more diverse and heterogeneous because, of course, they have not followed the same data structuring effort. What do we do with that? And this goes into directions of talking about legacy data and so on. But I will just throw it out there and tell you ontologies will have a big issue dealing with that. So there's we need to think about pragmatism here. Just 2 images that show the Living Archive as it is now. So it's a project that is developed now. We're working on the programming aspect. What I show you here is something that we want to highlight is, of course, exactly the data structure. So the structure of different types or aspects of data with each other. And what we see here again is something that we have seen in the figure before, is the structure of the layer. So the layers as a unit, which is a unit, and the spatial entities, that is somehow the encompassing class and so on. So what we see is the relationships of the data parts, and we can navigate those in order to see how things come together, how data merges in the data structure. And what we want to achieve is also trying to have people experiment in saying, okay, if I modify a certain relationship, what does this do to the data? And then we have something here that is an older version of where we are with the presentation of that data. When as soon as you have chosen, as you have selected a certain part of the data that you want to study further. This is, for example, the human remains. So we have here different attributes. We have here again a skeleton model that actually shows that the brighter the bone, the more present are those bones in the selection of data. So I think there are a lot of patella actually, and hand bones and so on. And here we see a GIS representation, but that's all not important. That's just where we are. What is the takeaway maybe of what I have said? And I hope there is a little bit of a takeaway. One point is there is no all-encompassing archaeological information system. So if I say this with a certain verve, then this means it's actually not there. And everybody that tells you, oh, we will develop something like this, it doesn't work just because there is no unifying theory as well. So thinking about data as something that derives and is based on assumptions, on human assumptions, makes it impossible to create an all-encompassing archaeological information system. Yet we can figure out ways how to map at least data to each other. Then understanding data models is relevant for new data. This is a little bit the approach that I showed you here, but as well as existing data, because, and then we talk about data mining that I have not really talked about, in at least not under the title, but it's exactly what we're doing with the Living Archive. We try to reorganize the data that we have and pull everything together. So we need to understand how data has been coming into existence in its structure in order to make sense of the data mining aspects. The problem then is not simply epistemic. Interpretations are changing. Archaeology is not an exact science. Interestingly, if we follow the philosophy of science again, just have a look back there, what happened after Binford, also the exact sciences understand themselves as not being so exact anymore. And the important aspects here are, in fact, not the epistemic ones, but what and how do we create our data structures. We need the collaborative aspect, we need the interdisciplinary aspect, and we need to allow for conceptual divergence. And that makes actually the thinking through of data structures something that is a little bit less dry, and I hope I have also shown you that, but actually something that is very theoretical and that allows you to actually also, in certain aspects, maybe understand your own project better when you try to push it into some raw data structures. And then there's no small amount of today's information systems that still tacitly accept data as raw. Fourth paradigm, new empiricism, blah, blah, blah. And they are then understood as a fallback device where truth is to be found. I hope it became clear that that cannot be the case. And then two last things. Brian Adams says, please, no punk. And the beauty of archaeology is analogous.
Thank you. Thank you very much, Dominik. I don't know if you can hear us. You can hear us.
No?
No, at all. No,
No, I don't.
Okay, I'm so sorry for the question. Probably, I'm writing. We have a lot of questions, but will be very difficult. But this is difficult to have them now.
Can you hear me now?
Yeah.
I cannot hear you. I have no idea why.
Yeah, we can.
Here we are.
We can hear you. Yeah.
I can hear you too.
So
sorry for the delay and all these things.
No problem. No, probably there is quite a lot of question. I know that we are quite late, but I'm asking to everyone if there is something that we want to know, or I don't know also if it's okay that sharing your email address if someone want to ask you something. Yeah. So in the meanwhile,
no, of course.
Ask you, Yashashwini, to turn on the mic and have the question for you.
Hello, can you guys hear me?
Yeah.
Wonderful.
Oh, thanks a lot for the presentation. So I understand the importance of creating ontologies for data as well as process of interpretation. However, the data which are left behind are chosen not to be included, are considered as obsolete. So how are they included into the ontologies? See, because you are actually talking about data and then again the process of interpretation. So how are these things part of it?
So it's a big problem, if you just have a look at the ADS and other archives that have done a lot of work, they have a lot of heterogeneous data there, and it's really difficult to bring those together. The problem is, or let's say like this, the approach in the end would be the same. So when we talk about, for example, let's just talk about structured data like Excel sheets and so on, and GIS files also that actually contain also table data, as we saw. It's possible, of course, to map those into the ontology because they follow already some kind of a structured information. Then, of course, we talk about, and that's maybe a more fascinating aspect of unstructured data. And this is what I mean when I say text files, PDF files, and so on. And of course, then the situation is much more difficult. Unfortunately, because that is actually the interesting part. Let's think about having a data structure, and of course, the archaeological excavation has been published, right? So there is actual interpretation readable, and we want to link those back together. Then we have to figure out a way how to do that. There can be a very basic way of marking up. So like in a HTML code of the PDF files, we annotate, we say, please highlight all the building numbers in the text, all the finds numbers, all the unit numbers, and so on. And when having the PDF file reside on the same archive, we can link those together. That is one aspect that is, of course, not very theoretical, not very, it's only giving you the possibility to read through by yourself. But of course, one can think about things like natural language processing, something that I mentioned for what we did with our programming code to understand the development of a system. That is actually not the normal case. The normal case is that you use it for English language, for also Latin language analysis, to analyze what the text, how the text is structured, what the text is talking about. Are there semantic structures in the text? And can we actually make sense of those by analyzing them with a certain way of artificial intelligence, what is behind, or at least machine learning? That would be parts and would be aspects how we can do this. We had another project where we tried to do the same thing, and this actually should point you in the direction that there is a long way to go before we actually can have machine learning do these things. We tried to analyze the pictures, the images. We have 150,000 images from the 25 years that are curated online. And we had some machine learning processes like Clarify or Google Images and so on walk over those images and see what they do with it. How can we train this, and what can we get out of it? And Claudia Engel did this at Stanford mostly. And what we found out is that the level of result of feedback from the AI is rather basic. So we can use it to tag, okay, there's bones in the image, or there's architecture in the sense of walls in the image, but really a relational statement like there is a skeleton in a ditch in front of a wall or something like this, something that we would be interested in understanding when we see the image, is not yet possible. So the theory here is existent. So it should be possible, but there is a long way to go technologically before we can go there, before we see that.
I think including what you said, see, I'm actually trying to look into an excavation report and then picking up the narratives and tracking back what are the evidences archaeologists use to come up to that narrative. So that's I'm reversing back, but I'm doing it humanly. So it's like by coding and other things. But the problem with what you are saying is, as you said, I agree that we won't be able to pick up the specific relational things, what you're mentioning clearly. But at the same time, how the data was used to interpret or come up to the interpretation. I'm not just talking about at the data level, but even the narratives, which are again ontologies. So that becomes a difficult task for the excavations which are already happened. So
yes, I'm with you there 100%. It's actually something that I did in my master's thesis, where I analyzed the excavations from the 19th century in Montbéliard, and tried to recreate the theoretical ontologies of conception of what a city is, and whether those structures, whether those oppida that are there can be conceived as cities. And that's called historical semantics, for example. You might want to look in that, but that's an interesting question, and I would be really happy to see your results there. That's really fascinating.
I'm actually using actor network theory to track back the actor and the process of translation to do that. So let's see what will happen. Thank you.
Wonderful.
Yeah.
Thank you very much. Thank you again for the PowerPoint presentation. No, really, I want to say something to everyone. How original was design with Elisa is part of data mining. We decided to have evening lecture about that in front of our aperitif, beers, or Venetian spirits, whatever, because we thought that was the only way to be able to absorb a lot of things. And so we squeezed 6 long aperitifs in 1 hour, 1 hour and a half. So of course it is only an aperitif of the actual thing that we want to do in the proper summer school next year. And Dominik has already agreed to be part of it, and so we will go on that next year when hopefully we can meet together and deal with that. Yeah. So
if COVID allows, yes.
Yeah. We hope at most.